Welcome to the chapter 6.5 lesson video. We're going to be talking about solving rational equations today. So far we've talked about adding rational expressions, multiplying, dividing, subtracting rational expressions. We have had just expressions, meaning two things that are either added, subtracted, multiplied, divide usually. But today we're going to have something a little bit different. Today we're going to have equations. Equations mean there's an equal sign involved. With equations, there are slightly different rules. Because there's slightly different rules, it just means the problems go a little bit differently. But these ones, sometimes they're a little easier, sometimes a little more challenging. We'll see how they go. All right, so we're going to talk about solving rational equations. I can solve a rational equation with cross multiplication. I can solve a rational equation using the least common denominator. And I can find the inverse of the rational function. This is actually a topic that we're not going to cover this year. It's something that we would normally cover, but this time around we are not doing it. Let's go ahead and get started. All right, so first off, we have four kind of tips and tricks that are going to help us with these problems. Okay, the first one says multiply through by the least common denominator. This is something we usually call fraction busting. Okay, so you're going to figure out what the least common denominator is. That's something we've been practicing a little bit. And if it's an equation, then you can multiply everything through, all the things, even the things that are not fractions, and fraction bust. That will get rid of all the fractions, and it'll leave us with an equation that should be much easier to solve. There are certain situations where we can do something called cross multiplication. So if you have just two fractions equal to each other, then you can do what's called cross multiplication. It's where you multiply the top of one side by the bottom of the other, and the top of the one side by the bottom of the other, and set the two things equal. That should be something you've heard of before, hopefully. And then one other thing we should do is, if it's a linear equation after we do this, we're going to isolate the x variable and solve for it. Or if it's a quadratic, we're either going to use factoring or the quadratic formula to solve. Those are probably our two best options. So really, there's kind of two first steps. You're either going to fraction bus or cross multiply if you can. Then if it's a linear, meaning there's no variables squared or anything, you're going to get the x by itself if it's asking to solve for x and solve for it. Or if it's a quadratic, you're going to use like one of the factoring methods or the quadratic formula methods. All right, so here you go. Here's our first problem, and you'll notice this is one of the situations that I just talked about. We have one ratio equal to another ratio. Since we have one ratio equal to another ratio, this is a situation where we can cross multiply. When I cross multiply, I kind of like to draw it like this, where I circle these two, and I circle these two, and it just helps me remember what I'm doing. I'm going to multiply 3 times the 4x plus 5. And I'm going to set that equal to the 9 times the x plus 1. Well, this is starting to look like a much easier problem. I'm going to go ahead and distribute for each of the parentheses. That'll give me 12x plus 15 is equal to 9x plus 9. I can go ahead and keep solving. I'll subtract 9x from both sides. I'll subtract this 15 over, so it's on the other side from the x's. So 12x minus 9x is 3x. 9 minus 15 is a little tricky, but that's going to be negative 6. Be careful about that negative. And then lastly, I'll divide both sides by 3, and I'll get x equals negative 2. There we go, we have our answer. Now there's one special thing, and I'm going to do this every time I get one of these problems. Remember we talked about exclusions before? Well, this is the one time I actually need you to check something. What you're going to do is you're going to look at your answer, x equals negative 2, and you're going to say, if I were to plug a negative 2 in here, or if I were to plug a negative 2 in here in the denominators, would it make any of the bottoms equal 0? Well, negative 2 plus 1, no. Negative 2 minus 4 plus, no. All right, so this is a valid answer. If it accidentally happened to make one of the bottoms equal 0, we would cross that solution off. It wouldn't be a valid solution. All right, well, this one's a little tricky. It's a little scary looking, right? There's a bunch of stuff going on, but this is actually another cross multiplication problem. We just don't see it yet. This 0 over here on the right-hand side, we can actually rewrite that as a 0 over 1. And now if you look at it, we have one fraction equal to another fraction, just like we did before, and we can go ahead and cross multiply. I'm going to multiply all of this bottom stuff by this 0, which is going to be nice. And I'll multiply all of this top stuff by the 1. Well, 0 times all of that bottom stuff is going to be just 0. And then 3x minus 6 times 1 is going to be just 3x minus 6. Well, how about that? That just got a lot easier. We'll go ahead and add the 6 over to the other side. We get 6 equals 3x. We'll divide by 3, and we get x equals 2. All right, so our x equals 2 here. This is our answer. What we're going to do, though, before we're done with the problem, is we're going to take that 2 and we're going to double check. 2 minus 3? No, that's okay. 2 times 2 is 4 plus, no, that's okay. And 2 plus 5, yep, none of those make it equal 0, so this is a valid answer. Sometimes I like to draw a little check for myself to tell myself that I checked to make sure that it was a valid solution. All right, let's continue. All right, this is a little bit different. No longer do we have just one fraction equal to another. We can tell these are separate fractions now because I have some plus signs and some minus signs separating out different fractions and constants. So what we're going to do here is something that sometimes gets referred to as fraction bust. Now, the reason we can do this is because of this equal sign. We don't normally get to do this with addition and subtraction problems. With addition and subtraction problems, we normally have to make common denominators. We don't have to do that here because we have this equal sign. So here's how I want you guys to do it. What you're going to do is you're going to figure out what the least common denominator is. Well, this denominator is a 2. This is a 10. Well, 10 has a 2 in it, right? It's 2 times 5, so we're still okay. We can use 10. And then this is a 5. Well, 10 also had a 5 in it. This is 2 times 5. So my least common denominator looks like it's going to be a 10. So what I'm going to do is I'm going to multiply this side by 10. So I multiply this by 10. And I'm going to multiply this side by 10. Well, what that means is I'm going to multiply each thing in here by 10. So I'm actually going to go ahead and I'm going to write that a little bit differently. Rather than writing a parentheses and a 10 like that so I don't forget, I'm going to go ahead and write a 10 next to each piece because I just multiplied both sides by 10. I'm distributing the 10 out here on the left side. All right, well, some of these fractions now reduce. I multiplied by a 10 on top. It's kind of keeping the equation balanced. I multiply everything by 10. Here, the 10 and the 5 are going to reduce and become a 2. Times this whole thing over here. The 10 and the 2 over here are going to reduce and become a 5. And then the 10 and the 10 are going to reduce, and they actually completely get rid of each other. If you wanted to rewrite a 1 left over, that's fine, but it's not necessary. We're going to multiply what we have left. We had a 5 times x. That would be a 5x. We had a 1 times 1. That's going to be a 1. We had 10 times negative 7. All right, so that's a negative 70. Equals, we have a 2 and we're going to distribute it to both pieces on the inside because that's how multiplication works. So 2 times x is 2x and 2 times 2 is 4. All right, now we get to do a little bit of reorganization and combining of like terms. I'm going to add so this is the equal sign. So if you like drawing the little fence thing, I know some of you guys do that from early on in math. I'm going to go ahead and kind of combine some stuff around. So I'm going to add a 70 over to here. I'm also going to subtract a 1 over to here. And then I'm going to move the x's to the other side. So I'm going to subtract this 2x over to here. So that'll give me 5x minus 2x is 3x. Equals 4 plus 70 is 74 minus 1 is 73. And then I got to get the x by itself, so I'm going to divide that 3 over. And so I'm left with x equals 73 over 3. Now, this isn't the prettiest answer ever. It's okay to have fraction answers. In fact, you'll get fraction answers a lot with these type of things. But that's fine. That's our answer, 73 over 3. Now, let's look at our denominators real quick. There's no x's, so we don't have to worry about if something plugs in and makes it 0. So we'll go ahead and leave that be. That is our final answer for this problem. As with any solving for x problem, you could always try and plug it back into the x values and simplify. It gets a little tricky with these ones, but that is something you can totally do. So this is our best way to show our answer. You find the common denominator, you multiply each thing by the common denominator, and you reduce them down to get your answer. All right, another one. This is fairly similar. Let's see what happens. We have a 6. We have a 3, and we have a 2. Well, 6 is 3 times 2, so that'll get rid of both of those. So our least common denominator here is going to be a 6. I'm going to multiply both sides by 6. I'm going to multiply everything over here by 6 and everything over here by 6 because I can do that with equations. Anything I do to one side, I can do to the other. So I'll multiply this by 6. I'll distribute it to everything over here. I'll multiply this by 6 as well. We'll go ahead and reduce. The 6's reduce. 6 and 3 leaves us with 2. And 6 and 2 leave us with 3. And now we can just multiply it out. The 6's reduced, that gave us just an x squared. 2 times 5x becomes 10x. 6 times 4 becomes 24. And then the 3 times 1 becomes a 3. Well, this is a quadratic. I see that x squared. That tells me it's a quadratic, so I'm going to subtract the 3 to the other side to make it equal 0. So I get x squared plus 10x. 24 minus 3 is going to be 21 equal to 0. Because this is how we solve quadratics. We make them equal to 0. Now, my hope is that this factors. All right, so that's my hope, is that it factors. If it doesn't factor, I'm stuck doing a quadratic formula, which is a little bit messier. But luckily, this time around, it does factor. What multiplies to 21 and adds to 10 is 7 and 3. X plus 7 and x plus 3 equals 0. Then I have to ask myself, what can I plug into each parentheses to make them equal 0? Or you can set them each equal to 0. You could go x plus 7 equals 0 and x plus 3 equals 0. And you can say, all right, what makes those equal 0? So my two x answers here are -7 and -3. These are my two answers for this problem. Nope, I should put an and sign between them, not a comma. So x is -7 and -3. Those are my two answers. Double check, no variables on bottom, so we don't have to worry about it plugging in. We're good to go. This is a good one. You could actually pretty easily plug these answers in and see that this makes a true statement. All right, now things are going to get a little trickier here. Now we have some x's on bottom and some numbers and an x squared. So we're going to go ahead and figure out what the least common denominator is, and it's really just kind of the same process. I'm just trying to show you some different variations these problems can take. So here, my least common denominator, well, all right, the first one has an x, so I need at least an x. This one has a 2x, all right, so now I need at least a 2x. And then this one has an x squared, so I need the 2, I need the x, and looks like I need a squared, so I'm going to have 2x squared as my least common denominator. So this gets multiplied by 2x squared, this gets multiplied by 2x squared. This should start feeling a little repetitive. This gets multiplied by 2x squared, and I'm going to reduce what I can. Here, the x squareds reduce, leaving me with just the 2. Here, an x reduces from these, leaving me with a just 2x, no longer x squared. And here, oh, sorry, that was incorrect. Let me go ahead and fix that. I misspoke there. So this was a 2x squared. So the x reduced, but the 2 also reduces. So this is going to leave me with just an x. All right, so this one over here left me with just a 2. This one left me with just, the middle one left me with just an x. And here now, just an x is going to cancel, leaving me with a 2x. Let me double check that. Yeah, that looks much better. All right, we're going to go ahead and multiply each thing out. 2x times 3 is 6x, plus 5 times x is 5x, equals 10 times 2 is 20. And man, that is a much easier looking problem all of a sudden. 6x plus 5x is 11x equals 20. Divide the 11 over to the other side, x equals 20 over 11. Box your answer. Now always double check, since we have some variables on bottom. Nope, that's not going to make a 0. That's not going to make a 0. That's not going to make a 0. So this is our valid final answer. All right, I think we got about 2 more examples, and this one's going to get a little trickier here. This one's a little messier looking. You'll notice we don't have these nice monomials on bottom now. Now I have a binomial. Now this is one time when I see a problem like this. Normally I haven't been factoring, and that's usually just something we do with the multiplication and division and sometimes the addition subtraction. But this one I'm actually going to do a little bit of factoring, and I'm only going to do it because I want to show myself something. I know, because I've done a lot of math, that when I see this x squared minus 4, it's made up of an x plus 2 and an x minus 2. I know that because I've done a lot of math. You might not recognize that as easily. So the first thing I'm going to do is I'm going to change this to be that factored part, x plus 2 times x minus 2. Without doing that, I sometimes might miss it, I might not see it. So my denominator over here is an x plus 2 and x minus 2. My denominator over here is just an x plus 2. My denominator over here is just an x minus 2. So what I'm going to do is I'm going to multiply it by the least common denominator, which is x plus 2 times x minus 2. Right? So that will help me get rid of all of my denominators, x plus 2, x minus 2. It's going to be a little messy looking, that's okay. X plus 2 times x minus 2, because we're about to cross a bunch of stuff off. So on the far right one, both the x plus 2's and the x minus 2's reduce and go away, leaving us with just the 9x squared. Here, the x plus 2 goes away and the x plus 2 goes away, and we're going to have a little bit of distribution to do in just a second. And then here, the x minus 2 and the x minus 2 goes away, and again, we'll have a little bit of distribution to do here in a second. All right, so let's go ahead and multiply some stuff out. On the far left now, we got the distribution 9 to x is going to make 9x. 9 to 2 is going to make 18. On the next one, we have 6 to x is going to make 6x squared. It's getting a little messy. 6 to negative 2 is going to make negative 12x. Equals, and then we have that 9x squared by itself, or this is really just a 1 over here, so we have 9x squared. All right, we're gonna go ahead, we're gonna move everything to one side and kind of compress things down. The biggest degree is this x squared, so I'm gonna move everything to that side. Even though there's an x squared over here, I know that the 9x squared is bigger, so I'm gonna move everything to the right side. So I'm gonna subtract all that stuff over. So 9x squared minus 6x squared from both sides. That's going to leave me with 3x squared. And then I have this 12x I'll add over and minus 9x. So plus 12x minus 9x is going to be plus 3x. And then I have this 18. So sorry, I did plus 12x. So that was plus 12x. Minus 9x, I didn't show my work on that part, minus 9x. That left me with the 3x. And then lastly, I'm going to subtract this 18 over to the other side. This is a little excessive amount of work. You probably don't need to show this much work, is minus 18. And so then on this side, left over is 0. I was moving everything over to one side, so I was canceling all these pieces out over here to get them all over to the right side. I showed a little extra work there. Well, now this is a quadratic again, so I'm going to hope it factors nicely. First of all, I can pull out a 3, so I'm going to get 3 times x squared plus x minus 6. And then I'm going to say, all right, hopefully this is a diamond problem. Anything multiply to negative 6 and add to positive 1. And luckily, 3 and negative 2 work. So this is going to become 0 equals 3 times x plus 3 times x minus 2. All right, so now our job is to ask ourselves, what can I plug in to make these equal 0? Well, the two things I can plug in is x can equal negative 3 and x can equal positive 2. All right, so these are my two answers, but there's something I have to do here. And this is, we've been checking it all along, but this is the first time it's actually going to matter. If I take my negative 3, I can plug it in here, I can plug it in here, I can plug it in here, and here, and there's no problem. But if I take my positive 2 and I were to put it there, 2 minus 2 is going to be, 0 on bottom. So what that means is this positive 2 is an invalid answer. So we just cross it off like that. It's not actually an answer. Our only actual answer here is negative 3. So if we want, we put a little check mark to remind ourselves that we checked it now. The negative 3 is good, but the positive 2 is not. And this is something that you have to do. This is a problem that often shows up on our tests, and so I really want to make sure you guys see this one a couple times. We'll try it again in class, and I'll make sure you guys hear about it again. But you got to check those answers because sometimes some of them end up being invalid. All right, we got one last problem, and this one's a little bit crazy because, we got alphabet soup. There's not too many numbers up here, it's just letters. And I know a lot of people don't really like that, but it is something we need to be able to tackle in an algebra class. So first thing we're gonna do is we're gonna figure out what our least common denominator is. Well, I got a B, so I'm gonna need a B. I got an X. This has an X as well, so that's good, and then I need a 3. So 3BX is gonna be my least common denominator. 3BX, 3BX, 3bx. I can multiply everything by 3bx, both sides of the equation. Let's reduce what we can. So here the b's are going to go away, here the x's are going to go away, and here the 3 and the x's are going to go away. Let's multiply what's left. I have a times 3x is 3ax. I have plus 3b times c is 3bc. And then that's going to be an equal to E times B is EB. Well, the whole point of this problem is to solve for x. So I know there's a bunch of letters up here, but I really want the x by itself. So I'm going to go ahead, I'm going to subtract the 3bc over to the other side. That'll give me 3ax equals eb minus 3bc. And then I want the x by itself, and I'm going to divide both sides by 3a. Divide by 3a, that leaves me with x equals eb minus 3bc over 3a. Now it's a little weird looking, but x is by itself, so I'm going to go ahead and say I have solved for x. All right, that's our last example for the video. Hopefully you've watched through this. If you need to go back and watch them again, I strongly encourage you to watch these examples as much as possible. We'll do another handful of problems in class together. And until then, if you have any questions, please reach out. Otherwise, I hope you have a great day.